Okay, it says we're recording. All right. So let's finish up on Chebyshev. We kind of stopped a little bit short on that. Okay, so the idea was Chebyshev's inequality. Before we do that, can somebody explain to me what the 68, 95, 99 rule is?
So it means that on the bell curve itself, like the middle section, about 68% of your results are going to be within that range, and then the 95, you go out even further towards the edges. 95% of your data is going to be in that range, and then at the very edge, it means very edge. You put another range, and 99% of your data is going to be in that range.
Okay, so that range is important part of the thing. You left it out all three times. So 68% of the data is between.
It's the
One
first
standard
deviation.
Yeah, or maybe I should say within one standard deviation. 95% of data is within. What's the next range?
2 standard deviations.
Standard deviations, and then 99.7% of data is within 3 standard deviations. Okay. Now this assumes, and this is a big thing here, assumes a normal or bell-shaped distribution. Okay. Now, where Chebyshev comes in here is Chebyshev says, okay, what if you don't have a normal distribution? What if you have a crazy distribution? Okay, is that crazy enough for you? All right, so that needs to go down. Okay, so this is a very not normal distribution, okay? So Chebyshev says, Chebyshev says, regardless of distribution, you have 1 minus 1 divided by k squared percent of data within k standard deviations, and then of course k has to be greater than 1. Now, so let's compare that a little bit with the normal distribution. So I don't know where the mean is in here. We're just going to make it, we're going to say that the mean is probably about right here, okay? So we're going to call that your mean. Okay. So what this says here, the k has to be greater than 1. So let's just pretend that this looks like it's got a little bit more variation. So that's 1 standard deviation. This will be 2 standard deviations, okay? In fact, I'm going to extend this up here. Okay. So what this is saying, oh, I made that blank here. Let's make it orange so it's not so, that looks a little better. Okay, so what we're saying here is, so if I go out 2 standard deviations, so this is -2, and this is +2. Okay. So 1 minus 1 over 2 squared, which is 4. So that's going to be 3/4, which is of course 75% of your data. 75% of your data are within 2 standard deviations. Okay. And so when you compare this, you're going to see, if I go 2 standard deviations up here, I'm going to have 95. So I'm going to have a lot more data within a normal distribution than I am within a non-normal distribution. And it doesn't matter how goofy your curve looks, your distribution looks. With Chebyshev, this is the relationship. So you can't do it for 1 because 1 minus 1 is 0, but it works for any value above 2 standard deviations. So does that make sense?
Yes.
Yes. Okay, cool. All right. So 19, looks like we got 19 people here. Is that right? Yeah, 19. So I guess somebody's not on camera. I don't know who that is. But at any rate, okay, so that is Chevychev's
So
formula.
what is
It's me. I'm not on camera because I'm at work.
Oh,
Yeah, I got called in. Sorry.
okay.
Thank you, though.
All right.
what is the K in that equation?
K is your standard deviations.
Okay, thank you.
Yeah. Any other questions? Okay, so that's the end of 3.2, okay, with Chebyshev, and then the 68, 95, 99 rule. All right, so 3.3, we're going to start dealing with grouped data, okay? Now, I'm going to copy this here because I think it'll be easier to show on Excel here. Okay, so let's see here. Okay, let's say this is somebody's, so here, this is funny to me. This is someone's schedule. Can you calculate GPA? Okay. Now, what's funny to me is most of you just say, just look at whatever it is on the school. And most of you don't know how to do this. So let me just do a quick question here. Do you know how to calculate a GPA or not know? I am curious here. Give me a thumbs up on which one of those best describes you. I must be really weird because I would always calculate this when I was in college because I wanted to know what my GPA was before the end of the semester. So 3 of you know. So the rest of you are going to learn something today. Okay, 4 of you know. Okay, so the 4 of you who know, can you help me solve this? So how do you calculate this person's GPA? It's easy to do in high school because all of your classes are the same number of credits, but it's a little harder in college where you have other different credit hour classes.
All right, so I know most of this. The only thing I don't exactly remember is the exact value of each grade. But I know like an A is obviously worth a 4.0, and then an A minus is
You need to know the
worth
grade
like a
points.
3.7.
Yeah, so
Yes.
A is worth 4. So we got 2 A's, so both of those are worth 4.
And then an A minus, is that like a 3.7?
Yeah, it's 3.6666666 goes on forever. Okay.
Okay. And then a C is a 2.0.
C would be a 2.0 and a B plus.
I think it's
What's
a
a B worth? Well, first of all, before you do B plus, what's a B worth?
3.0.
3.0. So a B plus would be
3.3 repeated. I'm realizing now it's just in thirds. It's been a while since I've done this.
All right. Okay. Well, you're one of only 4 people who knows how to do this in this class. Okay. All right. So do you know what to do next?
Yes. So now we have the number of credits. essentially we're going to calculate an average here, but we're going to weight it based on which one has the most credits.
Okay.
So for example, the first class has 1 credit, so that would be 1 instance of 4. But the second class has 3 credits, so that would be 3 instances of 3.3 repeated.
Okay. We're going to multiply
So
our credit
if,
hours times our grade points. Okay.
exactly, yeah.
And we're going to do that for all the classes.
Mhm. And then
Okay.
after that, we just take the average. Wait, no, that's not right. We divide by the total number of credit hours, not the number of classes, but the number of credit hours.
Okay. So we need the number of credit hours. So this
Yes.
person is taking 16 credit hours. And they've gotten this many points worth of grades, right?
Yes.
Okay. So to calculate the GPA would be,
It would be 55 over 16.
divided by 16. Okay. So this person would probably, if you rounded that to 2 digits, 3.44 GPA. Okay. And the idea here is the statistics class ought to be worth more grade points than tennis, because it's probably a lot harder than tennis. Tennis is probably just a participation grade. Okay.
Sorry, real fast. When you were doing that last step, I was writing it down. Did you just take the average of all the multiplications?
No, you take the sum, this 55, and you divide it by the total credit hours, which is 16. Oh, what happened here? Screwed up my formula somehow. The 55 divided by the 16. Okay.
So there's a 5 for statistics. Shouldn't that be a 4 underneath the grade point column?
Yeah, that should be a 4. How did I put a 5 there? Yeah, you're correct. Oh, that dropped her GPA down to 3.19. Yeah, you can't get 5 points for an A. You only get 4. So I must have made a typo there. Yes, correct. Okay. Any other questions? Okay. So hopefully, if we've got 20 people here, 16 of you learned something.
Yes.
Okay. Now, so that's great. The formula, basically, that we use for the mean here is this formula right here, and it works for both the population mean and the sample mean. And the idea with this formula here is you're going to take the sum of the, so let's do the denominator first. So F stands for your frequency. Okay, so frequency in this case would be your credit hours. You'd have a sum of 16 credit hours. Okay, and then you're going to multiply the, you'd have to figure out what the grade points were worth. So an A is worth 4 points, B plus is worth 3.333, A minus 3.67, etc. So you're going to multiply these together, and then you're going to sum these multiplication things here. So that's going to be 51 divided by 16, which works to be 3.1875. Okay. All right, so for those of you who say statistics isn't practical, then now you can say, well, look, now I can figure out my GPA. Okay. All right, now let me see. I think somebody, I don't know if this is, okay, that drives me crazy because I don't know if people are doing that. Okay, so the idea here is, if you come across some sort of data, let's say you wanted to figure out, we're going to do another example here because I know this is a little bit harder. Okay. So you're reading in the newspaper, you're trying to decide if you want to invest in this mutual fund company, and they give you this table here. So you don't have the raw data. Okay. So you've got 6. Here, let me do, I'm going to erase this here. You've got this table here. Okay. You've got 6 funds that basically 10 to 12%. You've got 14 funds that were 12 to 14, 10 that were 14 to 16, etc., etc. Okay. So I'm going to use this same formula that we just used with Michael. ENZD, did I say it right? You can just nod.
Yes, sir, you did.
Oh, good. All right. So my Italian's working today. Good. All right. So we'll use this formula here. And let's pick on one of the people who did not know how to do this. Alexander, you're at work, huh? We're going to pick on you on Monday for sure. Anna, can you help me figure out how to find the sample mean of this data set? And you're on mute, I think.
Okay, so do we first add them all together?
Add up all the frequencies. Yes, I guess I already did that. So you got 40. Okay, good job.
Okay,
What's
and
the
then we
next
divide
step?
them by the number that we have, the amount we have?
Divide it. So you're saying 40 divided by what?
7?
No. So that would give you the average number of funds you'd have in each of these groups. Okay. We want to know what the percent return is. So here's your hint. We need to find the midpoint of all of these things, and then we're going to multiply this times the midpoint to get a product, and we're going to basically do the same thing we did over here with the grade point average. So what would be the midpoint between 10 and 12%?
10.5. I mean, sorry, 11.5?
How about 11? The middle of 10 to 12 is 11.
Oh, okay, sorry, yeah. And then that would be 13.
What's the middle of 12? Yeah, 13.
14.
How about 15?
Yeah, sorry. 17.
Okay, yeah, there we go. 15, 17,
19,
19,
21, and 23.
21, and 23. Okay. So now, thank you, Anna, for doing that. How about Emily? Let's pick on you. Can you tell me what the next step is?
Now you would multiply. Can you hear me through my mask?
Yes.
Okay. Now you multiply the midpoint and the frequency together to get the products.
Okay. And we're going to do that for all of these. Okay. Now let's pick on Christian Dalton. What do we do next?
Now you would divide or I guess you'd get the sum first, right?
Yeah, we need to get the sum of the products, right? Okay, so that's 592. So what would we do next, Broderick?
You're going to take your frequency times by the sum of your frequency times by the sum of your product, right? And then divide that by your frequency.
You want me to add these two things together? Is that what you said?
Yeah, don't you? Well, it looks like you
No.
multiply them.
No, we're just so basically here's how this works. So x sub I, that represents your midpoint. F sub I represents your frequency. We've already multiplied these two together, so that's your x sub I times s sub I. Then we've got this summation symbol. So we've added all those up to get 592, okay? So that's your numerator. Then you're going to divide that by your denominator, which is
40.
40, okay? And so the average return works out to be 14.8%. Okay. So does that make sense?
Yes.
Okay. Now let me ask you a question. So that's the correct answer. Now, the first time I did this, and I'm going to pick on, was it Anna? No, I don't remember who it was. I think it was Anna.
Yes.
Anna had told me to just take this 40 and divide it by these 7 numbers, right?
Yeah.
Okay. We know this is the wrong answer, but my question is, pretend that you did it this way. Can you look at this number and know that it's wrong?
Yeah, it's
What?
way too low.
Way too low. Why is it too low?
Because our lowest numbers we have is 10 to 11.99.
Right. So the number's got to be between 10 and 24%. So 5.7 would be way too low. Okay. Likewise, if I got a number like 28, let's pretend I got 28. Why is 28 clearly wrong?
It's above all our other numbers.
It's above all the other numbers. Okay. So exactly right. Okay. So the idea here is look at your numbers here. You should get something in between 10 and 24. We got 14.8. That seems like a reasonable number. Okay. Does that make sense? Okay.
Can you just
All right.
explain the values in the formula again, like what each of the values means?
So these are the
No, for the actual formula.
Oh, you're talking about this x sub I?
Yep.
So x sub I is going to represent your midpoint, or in the case of your grades, you'd have to figure out what an A would be translated to. So an A would be 4 points, C would be 2 points, a B would be 3 points, and et cetera, et cetera. Okay. So x sub I is going to represent either the midpoint, or in the case of the grade, it's whatever the A is worth. Okay. F sub I is your frequency. Okay. So this is going to be so we've got 6 funds that are between 10 and 12%. Okay. So we're going to find the midpoint. So the midpoint between 10 and 12 is 11. The midpoint between 12 and 14 is 13. The midpoint between 14 and 16 is 15. So you've got to figure out this midpoint yourself. And the midpoint's going to be smack dab in the middle of whatever these groups are. Okay. So we're going to take our midpoint, we're going to multiply it by our frequency. So 11 times 6 is 66. We're going to do that for every single thing here. Okay. So that's why x sub I times f sub I. Then this weird looking E, which is actually the Greek letter S, we're going to add those up. That's going to be the 592. And then the F is your frequency. The frequency is we had 40 funds in there. Does that make sense? I don't know who asked that, but does that make sense?
Yeah, it does. Thank you.
Okay. All right. So, all right. So yes. So once again, this is what makes it hard. I don't know how I'm going to make this a multiple choice test or a quiz tomorrow. But definitely I'll be giving you some sort of a table, either a grade point average or something like this. And then I'll say, I want you to calculate what is the mean rate of return, okay? So on your formula sheet, in fact, this is directly copied from your formula sheet, the population mean for group data and the sample mean for group data, those formulas are exactly the same. So it doesn't really matter whether it's a population or a sample. The weighted mean is basically the same formula. Instead of using x sub I, we use the w sub I and f sub I, xi. Basically, these are all 3 of these formulas are the same. Okay. Now, what comes in tricky here, we'll probably spend the rest of our time on this because we've got these 2 formulas here for the population standard deviation, for the group data. So these two bottom formulas here. I'm going to copy this. So we're going to go back to the standard deviation. We're going to figure out what is the standard deviation for this. And so now remember, and I know these formulas are going to look pretty funky here, okay? I don't care about the top three because we've already done those, but the population standard deviation. So remember the Greek letter sigma, this looks like a zero with a tail on the top of it. Remember when we're dividing by the population, we're dividing by n. So you can think of the sum of your frequencies as your n. And the sample standard deviation, remember we use n minus 1. So think of this as your n minus 1, okay? So now we've also got these other formulas that some people prefer to use. So we're going to do this. In fact, we're going to do it with both data sets. I think that's probably going to take up the rest of our time. And we're going to do this for both of these data sets here. So I'm going to go ahead and I'm going to do the first one first here, okay? So this one's a little bit trickier, but as we look at our formula, basically you can think of x sub I as your data minus your mu. We're going to square it, then we're going to multiply it by the frequency, then we're going to sum up those products and divide it by n, essentially.
Sorry, what's the mu again?
Say it again.
What's the mu again?
Mu is your population mean.
Oh, okay.
Yeah, so yeah, population mean, sample mean. So yeah, x bar is your sample mean, mu is your population mean, okay? And remember, in both cases, those are the exact same formula, okay? So we've just figured out our sample mean. So this is so we'll assume, since this is for one student, we're going to assume this is a population, okay? So we're going to use this top formula, and then on this one here, we'll assume that this is a sample, okay? Sample of 40 funds, okay? And so we'll use the bottom formula for this one, okay? All right. So, all right. So here, I'm going to move this because you're in the way. Okay. So here's the idea. So we're going to have to take x bar. So I'm gonna use this first formula right here. Okay. So as we look at this formula, and this is where you're going to have to get really good at using these formulas. So remember, on your tests and quizzes, you can use the formula sheet. And if you haven't seen the formula sheet yet, hopefully you have by now. But if I go to announcements, and if I go to the book tables here, okay, if you haven't printed this out yet, you're definitely going to want to print this out. But you've got your formulas and tables. All of these formulas, you don't have to memorize them, but they are on here. So you've got them in chapter 3. And in fact, here's your population mean from group data, your sample mean from group data, your weighted mean, which is the exact same formula, just with different letters. Here's your population standard deviation, which is what we're doing, and your sample standard deviation, okay? You can see what we've got left to learn in here. We're probably not going to learn that today, okay? This is a little bit trickier stuff, okay? All right, so as we look at this, I need to find x. I'm going to put this as x minus mu, okay? Except for I put that in the wrong spot, okay? So in this case, when we're looking at, remember, this is our original data set here. Okay. What do you think would be the x and what would be the mu?
Would x be your credits?
No. Mu should be the easy answer. What's the mu?
that going to be your grade points?
Yeah, your grade point average. So basically, yeah, this is your mu right down here. Okay. So X would be your grade points though. Is that what you meant, Broderick?
No, I was thinking mu was the grade point, so I was wrong.
Okay. All right. So in this case, yeah, your X is going to be your grade points. So we're going to take the 4, we're going to subtract off 3.1875. Except for that's supposed to say equals, not subtract. Okay. So X minus mu, and so we're going to do this. Okay, so we're doing inside the parentheses first. So in this case, we're taking the grade points. Maybe I'll do it this way. And we're subtracting off mu every time, okay? So we're going to subtract 3.1875 every time. So 4 minus 3.1875 is 0.8125. 3.3 minus 3.1875 is 0.145. 3.6 minus 3.18 is 0.479. 2 minus 3 is -1. 4 minus 3 is 0.8. Okay, so we've just done the inside of the parentheses. Okay, so let's ask Victor, what is my next step according to this formula right here?
Can you hear me now?
Very softly.
Do you square what you got?
We're going to square it. Exactly right. Okay, so we're going to take this number and we're going to raise it to the second power. Okay, now remember, you guys are going to be doing this on paper and pencil, not on a spreadsheet. And so please, when you're doing this, make these nice labels so that I can figure out what you're doing. Because if I can figure out what you're doing, I'm going to at least give you partial credit, even if you get it wrong. And if I can't figure out what you're doing, I'm going to be like, yeah, I'll give you 1 point for trying or something, okay? All right, so we've just taken X minus mu, we've squared it. What is the next step according to this, Mia?
You need to times it by the credits.
Yes, so we're going to multiply by the credits. Very good. I like that you use the thing in here, okay? So we're going to take this squared number, we're going to multiply it by the credits, okay? We're going to do that for everything, okay? The next step is what, Caitlin?
I have a question on that last step, actually, real quick.
Okay.
I like their individual like credits, like the 1, 3. Does that make sense?
No. Say that again.
So those numbers, taking it, are you multiplying it by the total credits, like that?
So
or by
yeah,
like the
so
actual credits, which is like the 1.
yeah, so the 0.66 times 1 is 0.66. The 0.02 times 3 is 0.06.
Okay.
The 0.22
Okay.
times
Got
this 3 is 0.68, etc. Okay?
Okay.
All right, so we've just taken care of, we've subtracted the data minus the mean, we've squared it, we've multiplied it by the frequency. What's the next thing we're supposed to do according to this formula?
Divide by the frequency.
No. I was going to ask Caitlin. What's the next step, Caitlin, according to this formula?
Do you divide by the GPA?
Nope. What does this mean here? This funny looking E,
So
which is the capital sigma.
Your midpoint?
Nope. When you see a capital sigma, I think somebody else said it. Sounded like a male voice. When you see capital sigma, what does that mean?
Sum.
It means find the sum, okay? So we need to find the sum of all of these products here. And if you're looking at Excel, see, even Microsoft knows, oh, that weird looking E, that means sum. So we're going to add up this column right here. Does that make sense, Caitlin? Caitlin went on mute. You can at least nod.
Yeah, it does. Sorry.
Okay. All right. So we found the sum. So we found the numerator now. Okay. Now, I know Broderick was trying to go here, but he went too fast. But now we can do what? What are we doing next?
Sorry, I was muted. You divide by the sum of the frequency.
Divide by the sum of the frequency. And the sum of the frequency in this case is?
Should be 16, right?
16, correct. Okay. All right, so what is this step called? This step has a special name. If Jonathan remembers. Do you remember, Jonathan? What is the special name for this step?
Sorry, I kind of blanked right there. The special name of which step?
This step that we've taken everything in here where we haven't done the square root yet. So what is before we do the square root, what is that called?
Before we do the square root?
Yeah, it begins with the
What is that
letter
called?
V.
The variance?
The variance, thank you. Okay. And then the last step here, after once we've got the variance, is what, Paul?
We square root it by the standard deviance.
Root. Okay, so we're going to take the square root of the variance, and that's going to give us 0.833. Okay. Now, the question that I have here for y'all is, does that seem like a reasonable square root? And why? Sorry, does that sound like a reasonable standard deviation? That's what I meant to say.
Yes.
That sounded like I was. Somebody said something, but I didn't hear what it was.
I said I think so.
You think so because why?
It's just like it's not jumping too fast to different grade levels, so it seems like it would be a reasonable standard deviation.
Yeah, we've got a 4-point grade scale here, right? This goes from 0, really 5 points if you count 0, because if you get an F, you get a 0. So 0 to 4, you've got 5 grade points. And so this is less than 1. So that seems reasonable. Okay. All right. Now, go ahead.
Why did you take the variance?
Well, the variance is always the step before the square root.
Oh, I didn't know that.
Yeah. Yeah, so the step before the square root is the variance. So no matter what it is. All right. So let's do this again. We've got only 5 minutes left, so we're going to have to move a little bit faster. This time, we're going to try to use, we're going to treat this as a sample. So I'm going to use this one down here. Now, so rather than divide by 40, the denominator, I'm going to divide by 39, right? Because I'm treating this as a sample. But what I would like to do, instead of using this one, I want to use this formula here, okay? And usually when I do this, some people like this formula better than others, okay? So remember, we've found our sample mean, which in this case is 14.8. Okay. So if we're doing this, I need to find xi squared. So what would be xi quantity squared? Let's pick on McKay. Can you tell me what would be xi squared? So we're using this formula here first. What's the xi?
To be completely honest, I'm unsure.
Okay. I'm going to jump in here because we've only got 5 minutes left. That's going to be your midpoint. So your xi represents your midpoint. So we're going to square that right off the bat. Okay. We're going to do this down. Okay. So I'm going to pick on you again, McKay. What do you think the fi represents in this case?
I don't know. I'm not grasping this. I'm sorry.
Okay. So we need to multiply the xi squared times the fi. Fi stands for frequency. Okay, so we're going to take the xi squared, we're going to multiply it by the frequency, which in this case is 6. Okay. I'm going to give you a third one, which hopefully you will answer this question because you've seen it enough. What does this Greek letter E look like, or sigma? What does that mean?
The sum.
Sum. Yay, finally. All right, so we're going to add up this sum of this column here, okay? So we've just added up, so we've done this first part. Now we're going to do some subtracting. And in this case, I've got the sum of xi fi squared. Okay. Now, I need to find out what xi times fi is. Okay. So now, Sarah, can you tell me what xi times fi is? What do I multiply together?
The midpoint times the frequency.
Very good. The midpoint times the frequency. Okay. So we are going to multiply all these together. So we've got the xi times the fi. And then we need to find the sum of that, okay, which is 592. And we're going to take this sum and we're going to square it. So this 592, we are going to square that. And then we're going to divide it by what? And so that would be Hayden. What do we do? So we've got this numerator right here. Sorry, I should be down here. Got this numerator right here. We're going to divide it by what?
Sorry, I was on mute. The sum of the frequency.
Which the sum of the frequency in this case is?
Oh, you wrote it somewhere. Is that 9,168?
40.
No, it's 40.
Oh, there it is.
Yeah, it's 40. Okay. All right. So I've got 9168, which is this piece. Sorry, this piece right here. We're going to subtract this piece right here, which is 8176.6. Okay. So this is going to be the top. So this is going to be 9168 minus 8761.1, which works out to be 406.4. Okay. So this is your numerator. Now, what are we going to divide our denominator? We got a denominator here, and in this case, because we're using a sample, what is this value here, Zach?
So would it be 40 minus 1, so 39?
Yes, perfect. So this is going to be 39. So we're going to take our numerator, 406, divided by our denominator, which is 10.42. What is this step called, Keaton?
Sorry, I was on mute. Is that the standard deviation?
Nope. It's the step before the standard deviation.
I don't know what it would be then.
Begins with the letter V.
Oh, variance.
Variance, thank you. Okay.
Yep.
And you need to know that we need to take the square root. And so I'm going to take the square root of that number there. And that's going to give me 3.22. Okay, now we've got a mean of 14.8%. Does this seem like a reasonable number?
Yeah.
Yeah, so about 3% standard deviation. So, okay. All right, so now Jed's leaving and we're out of time anyway. So this is your homework. This is going to be fun homework, okay? So I don't know how I'm going to make, I might have, this one might not be multiple choice. I might have to make you do some math on this quiz. We'll see what happens. I hate grading the quizzes when we do that though. So, all right. So that's 3.3. So your homework this weekend is going to be 3.3. And so any questions before I let you guys go?
I was just gonna ask, so like on tests and quizzes and stuff, will you label stuff like, I'm looking for the midpoint, frequency, all that? Because like with the grades and all that, it kind of throws me off because I'm trying to decide what's what. Does that make sense?
The grade point average you were more confused on, is that?
Yeah, just because it's like, I'm used to thinking XI as being the midpoint and then FI as a frequency, but with the grade point average one, they weren't like that.
Yeah, but I was hoping that you would know that an A was worth 4 points and a B was worth 3 points. So you can still think of it as a midpoint, but you just have to know what the A and the B stands for.
Okay.
So
I do have one more question. So both those formulas, they had two variations. Would the longer variation, the one which is the one we just used, would that be in the case you don't have the mu or you don't have the you just don't have the information that you need?
So in either case, you can use either formula. Some people like this second one better than the first one. I actually like the first one better than the second one. I just wanted to show you that you could do it both ways, and that was why I did it that way. But use whichever one is easier. Personally, I think the first one's easier to use, but the second one works as well.
Awesome, thank you.
Any other questions? All right, well, I'm going to stop recording, so good luck. Reminder, next week we're going to have a test on Thursday. So a week from today we will have a test. We'll definitely cover 3.4 tomorrow, or Monday, I mean. So
Tuesday?
Wednesday.
Oh, Tuesday, you're right, because Monday's no school, so Tuesday, right. Yeah, so enjoy your long weekend.
Woo.
Okay.
Is the test going to be in class?
Yeah, so rather than meeting in class, I'm going to set the test for 8 o'clock, and you guys can take it. We just won't plan to meet. You'll just do the test instead of meeting that day.
Sounds
Okay.
good.
All righty. Thanks. See
Thank
you all
you.
on Tuesday.
Thank you.
Mhm.